Okay.
Thank you very much, Alessia, for the kind intro. I guess most of the people are still standing in a crowd in a line for waiting for their food. But great that you made it here. And today we want to speak about NewSpace and satellites. As Alessia said, my name is Joram Voelklein, a partner of Alpine Space Ventures. We focus on the European NewSpace sector. And maybe we start with a brief introduction. Walter, tell us who you are.
Hi, nice to see everybody. I'm Walter. I'm CEO and founder of Reflex Aerospace, a company based in Berlin and focusing on the rapid manufacturing of small satellites.
All right, I'll go next. I'm Bulent Altan. I have two roles. One of them is being the, together with Joram, we started Alpine Space Ventures, a venture capital company investing into companies like Walter's who are promising a complete bright future in the space sector. But I'm also the CEO of Mynaric. It's another Munich area company in the space sector. We're building optical communications that connect all of these satellites together. Been in this industry now for 2 decades, in the new space industry, from the start where we started SpaceX, was there as a VP and until recently, and then came over here, joined forces, and here we are.
So, as I mentioned, we invest in NewSpace. What is NewSpace, actually? Maybe, Bulent, you want to make a quick differentiation between NewSpace and classic space or old space or whatever you want to call it.
Sure. I think we get this question a lot. So what is actually NewSpace and why are people talking about it? Aren't we in the space industry now since the end of the Second World War? People have been going into space exactly out of the technologies coming out of that. What is new about it? What's different about it? As I said, the space industry has existed for quite some time. It was very much driven by strategic, by military, by governmental interest. And that really drove the space industry up until about the start of the century. Right around that time, we realized that space can do more in our lifetime than just looking at our enemies and maybe doing a strategic projection of power. It can probably play a big role in society, actually integrate itself into different industries. And enabled by new technologies, by rapid prototyping, enabled by some of the, let's say, West Coast Silicon Valley mentality, people have started looking into space with an entrepreneurial mindset, building up business cases, really thinking about space as another place to be entrepreneurial. And what really defines new space versus, let's call it, classic space, is the fact that we are not talking about companies doing business just because a government tells them to do something and then they do that contract with maybe a fixed set of profit on a cost-plus contract, but people are really gathering VC money, building up companies that have scalability, that have business plans, and behind that is now the whole new space industry. We see commercial rockets, we see space tourism, we see satellite internet, we see Earth observation for commercial practices, agriculture and whatnot. So that's really what defines new space for us.
And maybe to sum it up, you could say that old or classical space does things as good as possible, and new space does the same things as good as necessary. And this, of course, is if you do it as good as possible, it's quite a burden on your cost structure. So, Walter, why are you building satellites and not something else?
Well, I think that space gives us the possibility to solve a lot of very global, very existential challenges which we are facing as humanity. We see that right now that the ideas, the constellations built by the US Americans, like help in the war in Ukraine, but it's much more than that. The remote sensing capabilities which are being used more and more can be used, for example, for tracking CO2 and other gases, yeah, and in the context of the climate change and then the challenges connected to that, space is something we simply need. And on the other hand, we see that the access to space is becoming cheaper and more affordable, which leads to a huge demand for satellites. So I guess the projections for the next decade are somewhere around 35,000 satellites which need to be built within the next 10 years, right? And the real number will potentially be even higher. So, and somebody needs to do it, and this is why we are building satellites.
And when you compare what you do to the classic space industry, what are you doing differently?
We have a leaner approach. Like in the classic space, historically seen some approaches were used like to make the governmental customer happy, which means documentation, certain order of steps and processes, right? So the typical project in the classic space takes 4 to 5 years. We try to accelerate that by like removing all the unnecessary clutter from the process. And I guess this is also part of the NewSpace definition, I would say. Right? So we aim on shortening the cycles to less than a year in the end, right?
Maybe if I can add to that, I think the biggest deal that we see in the NewSpace companies, that differentiates them very often to the classic space is, you alluded earlier, what is as good as necessary. And as good as necessary very often is actually even more innovative than what classic space does. But it's really cutting out that fat layer out of the space industry that has built itself over the years. I think the space industry, we all know, it's a difficult domain. It's a very hardware-heavy domain. You don't get to test your hardware very easily. We all know it's very public. When a rocket fails, it doesn't go very silently. The failures are very visible. So over the many decades, the space industry built itself a little bit of a callous skin, where it really was going after the failure is not an option, first time right approach. And what that meant is, do not take any risks, and do not try anything out of the ordinary. Try to build based on heritage technology, build satellites in the 2000s, still based on technologies of the 60s. And what that meant is they were having some fantastically reliable hardware that could do nothing. And that came with a fantastic price tag. If you were thinking about it, today, up until about 10 years ago, it was perfectly normal that a space company would pay a chip maker to keep on building this one chip that was built in the 60s and had no other use. And the whole factory would be kept online just so they can build that whole satellite still, rather than just go ahead and trying out something more modern. And what really sets NewSpace apart is they see that as an unnecessary cost, unnecessary complication. And they just innovate, try something, 99% it actually works, and they take that 1% risk on, but realize that the bottom line is going to really move the company's economics forward. So that is one of the biggest cost-saving structures of NewSpace. And actually, that's yet another, I would say, characteristic of NewSpace. That risk-taking, that smart risk-taking based on economics that really sets them apart.
Due to the sad events in the Ukraine, obviously we read about Starlink a lot in the news. And you served 12 years at SpaceX, and in the end you were in charge of the Starlink program. What is your take on the future prospects of Starlink, and how will it change? What will it change, and how will it change military or also communication in rural areas?
I think, first of all, we have to realize that communication is one of those domains where there is unlimited demand. If you look at our mankind's consumption of bandwidth, it's one of those things that you can grow exponentially, even beyond Moore's law, and you would still not be able to be enough for what people are looking for in terms of bandwidth. I think our content is getting much more bandwidth intensive. Our everyday life is getting more bandwidth intensive. People working remotely is making us more bandwidth intensive. So it is only natural that people are going into the communications domain, and they are serving the whole world globally out of satellites. About 60 years ago, when the world was just working on the computers, and they were the first computers and computing centers were coming alive, the thing that really changed that when we started connecting them all together, and what was ARPANET then DARPANET became the internet, and that really shaped the way we do anything here on Earth. Today, life without internet is not possible, and space industry is really going into there. What Starlink is doing today is, instead of only connecting people in city centers, they are giving a complete global connectivity everywhere, and one that is very resilient to hear events on Earth. Those events don't always have to be war either. It can be a natural disaster. It can be a certain amount of accident. We constantly have every now and then a undersea cable break. These cables just lay on the bottom of the ocean floor. So it gives a resilient infrastructure. It gives a ubiquitous infrastructure all around the world, and that's what the prospects of Starlink is. It's coming in there. It's selling every bit of capacity it has, and they keep on launching, and they keep on selling more. And I think they're going to be very successful. Already today, SpaceX makes more money with Starlink than it does with all of its other programs combined. So I think this is a trend to stay, and I think the future holds not just Starlink alone. There will be tens of constellations doing different type of connectivity in different geographies for different type of end segments, and we're going to see quite a bit of actors in this realm.
If I may add, it's dangerous to think that space, or at least the near-to-Earth space, is an unlimited resource. It's not like that. Yeah. So there will be lots of constellations, but there are two things. First is space traffic management, which is important, because if we start to build our super important infrastructure in space, we must make sure that it cannot be damaged. Right, and it's important that we don't have the Kessler effect and lose the orbits. So it's important to deorbit all that stuff. We need some regulation here as well, right? And the other limited resource is spectrum, RF spectrum. So you cannot have a limitless amount of constellations all using RF. You will simply not be able to use any one of them, right? Needs to be considered.
And next to AI, space in the VC arena is certainly one of the super hot topics these days, and also for the next years. And that also means that industries that don't have touch points with space today will also move into space. Walter, from your perspective, could you tell us a bit more about how your client structure looks like, and what are companies that don't have overlaps with space today, but according to your view, will have overlaps tomorrow?
Well, right now the client structure is as you would assume it for a satellite company, right? So it's typically governmental, some commercial companies mainly interested in data from space, remote sensing, and similar missions. But what I think will change in the next decade, or maybe decades, is that similar to the automotive market or to the mobile phones, there will be a secondary market. So right now every satellite is built in a way that it's used for a couple of years, then it's deorbited and it plays no role anymore. This leads in some situations to a situation where a good asset, which simply has no use anymore for the owner, is deorbited. And we think that there will be a market where used satellites will be resold, and organizations which could not even think about buying a satellite or using satellite data actively will be able to do it. And here I'm thinking also about NGOs, for example, Greenpeace or Sea Shepherd, where satellite data could make a change. Right? And this is simply not accessible in a way these organizations could afford it right now. Yeah.
And what would you identify as the most promising sectors within this arena?
From the commercial perspective?
Yeah.
From the commercial perspective, we see that more than 80% of the missions are connected to communication. Right? So connect the unconnected, bridge the digital divide. These are the buzzwords which are being used in this context typically. And I guess there is a huge opportunity here. We are standing at the beginning of something big. We know that Starlink was mentioned. There is also OneWeb. We think that in the context of sovereignty of Europe and the European countries, we need also to establish something European here. Commercial European, and this will be a huge driver for the industry on our continent in the future.
Yeah. Maybe I'll add to that. I think it's good to kind of give a little bit of an image what that really looks like. Today we talk a lot about the automotive sector, but what does the automotive sector really have to do with space? What can we do for them? If you think about it, one of the next steps for automotive to take is autonomous driving. And And that is not something you can afford only to have in areas where you have connectivity. And every time you go into the ever so famous Funkloch, your car does decide to take a turn towards the next tree. You need that to be ubiquitous. You need that your autonomous driving to be available everywhere. And it is not really feasible using terrestrial technology to connect every single spot on Earth. But satellites, the way they tend to be doing things globally. And that's what we are seeing. For automotive companies to share data between cars, to make really not just a single car intelligence, but actually looking onto swarm intelligence, really sharing data, being the sensors of each other. One car seeing a single pothole and telling the rest of the cars, hey, by the way, I just hit a pothole here, so watch out. That's the kind of intelligence that really makes a difference to the end consumer, and it's one that requires connectivity everywhere. So that's one, really learning from each other, doing machine intelligence above the context of a single car, but making a ubiquitous connectivity between all of them, and doing that swarm intelligence. That's an interesting one. Another one is Earth observation. Today we are looking at the Earth. When you look at a Google map, in the best case, you're looking at an image about a year, 2 years ago. Most of the time, that's augmented by aerial photography. What about a view of Google Maps that's actually live or quasi-live? With capabilities like network satellites, my company works on in Mynaric, really connecting satellites with each other, building the internet up there with lasers. You have possibility of ubiquitous observation of Earth any given time, being able to find out wildfires as soon as they arrive and not an hour later, being able to find if there's a parking spot open, or being able to see if there is poaching or illegal logging going on. These are all things that make a difference in our lifetime, and could very well be kind of the sensor network that keeps an eye out on our Earth, the one resource we have a very limited of. And you're going to hear this more and more about space. Very often space is about Earth itself, and that's what we serve here.
Today we have like roughly between 5,000 and 6,000 satellites up there, I believe. You just said that until the end of the decade you would say like we will have like 35,000. There are even numbers that say like 50,000 or 100,000. What could be a challenge to that type of growth in your view?
Yeah, well, I mentioned it a couple of minutes ago. So, like space traffic, it's very crowded out there. Like it's already now crowded. We had like 2 events I can recall, and we had like since the ASAT, anti-satellite weapon tests, the Russians did, and a couple of other nations did. It's becoming even more dangerous there. And again, like this is, from my perspective, the biggest challenge. This is a resource which is not unlimited. So we need to make sure that there is a reliable regulation which forces also commercial operators, which are naturally oriented towards profit, like us as well, obviously, to deorbit the satellites. Yeah. And the challenge about deorbiting a satellite is that you need a cooperative satellite for that. It means when you select to deorbit it, it's working, it's generating revenue at that very moment. So and this is the task we need to solve.
Yeah. Yeah. Maybe on that topic as well, to add a little bit more, we have this whole problem of, from the 60s until the 2000 era, we were quite irresponsible with the use of space. Satellite deorbiting was not the norm, especially rocket deorbiting was not the norm. A lot of second stages, third stages, upper stages were left there that just go there uncontrolled, dead, and some of them even with a lot of pressure in them, and then they collide with something, shatter parts everywhere. Today, the number of satellites is 6,000. If I distributed 6,000 cars all across the globe, they would not even see each other. It wouldn't be that big of an issue. But the problem is the amount of small little things we have. We have millions of tiny little pieces, couple of millimeters, traveling at 28,000 kilometers an hour, trying to hit your satellites and take them out of order. And we need, besides the orbiting, a better tracking of these objects. We need better space traffic management. We need a way for all these satellites to go ahead and dodge those hypervelocity bullets up there and stay alive. And that's probably one of the topics that we will be looking at with our venture capital, is looking into better tracking of debris, how we can monetize that, how we can really increase the capabilities there, because that's really the main risk that we are seeing here. But again, if we had good data and we had responsible space missions, there's plenty of space in space, and it's a 3D problem. I think we can pack it quite full. It just requires a certain amount of responsibility and an eye into the sky.
Walter and Bulent, thank you very much for your insights. It was very interesting, and yeah,
Thank you.
great success to all of us.
Thank you.